This is Chapter P, Prologue, Calculator Information. Part 1, Calculators. We'll be using the TI-83-84 family of calculators. All of our keystrokes, methods, and procedures are geared toward the TI-83-84 family of calculators. If you use a different calculator, a different brand, like the Casios, it is your responsibility to learn how to use them. So from now on, when we say calculator, we mean the TI-83-84 family of calculators. The 84 just has a little more memory than the 83, and some of you may have the newer 84s that will graph and color and everything. So it really doesn't matter if you already have a TI-83. You don't really need to update anything new. The 83 is good enough for what we're going to be doing. So you're not allowed to use a calculator that has a computer algebra system. Like specifically, you cannot use the TI-89, the TI-92, the TI-Inspire, the TI Voyage 200, or something that's equivalent to them. If you're unsure about whether or not you're allowed to use your calculator during a test, like the final exam, just ask me and I'll let you know. Also, you're not allowed to use your cell phone as a calculator. The intent is that you use either the TI-83 or the 84 or something equivalent to them. Now, there's information on how to download a TI-83 or TI-84 to your computer in the course documents folder that's in the content browser area of our D2L homepage. It is in the calculator subfolder. So if I have time, I may show you to do that in class, but most of you probably already do have an 83 or an 84. The 85, the 86 are actually older calculators. I'm not really sure if they will work for what we're going to be doing. So typing mathematical expressions. We need to learn how to key mathematical expressions to our calculators. The advantage of the TI-83 and the 84 family of calculators is that the way mathematics looks when we write it, or the way it's going to appear on our screens and notes and everything, is the same way that it's supposed to look on your calculator, with a few exceptions. And those exceptions can become very, very important, because you'll get an answer, but the answer won't be correct. So we have the following keystrokes for certain special math operations. Now, some of you, if you've used the 83 or the 84 in high school, you're used to them. So the power key, this thing is called a caret. Okay, but that's the power key. So for example, to type x to the fifth, you would enter it like this: the x key, your caret key, and then just 5. So you'd see something that looks like this. Now I was using the TI-84 that I've downloaded into my computer. So if you're using the 83, it may look slightly different. And I know on the 83, you'll actually see the caret and the 5. The nice thing about this is sometimes called pretty print. Most of the newer 84s will actually make it look like this. This would actually be flashing in the live calculator, and you would actually have to use your navigation keys, which are those arrow keys, in order to get out of the exponent, because if you kept keying stuff in, it would just be up there in the exponent. So every once in a while, you really need to look at your calculator screen to see are you where you think you are. So if a numerator or denominator contains any sort of operation, such as addition, subtraction, multiplication, division, and so on, then the numerator or denominator must be enclosed in its own set of parentheses. If you get in the habit of doing this, you'll be okay, but leaving off the parentheses for a numerator or denominator that needs it is usually what leads to some severe mistakes. So for example, if you're doing 5 plus 9 all over 4 minus 12, you would have to enter it into, in parentheses, 5 plus 9, then divided by, that's the fraction line, that, all over in parentheses 4 minus 12. So the calculator, you would see this. You would actually see that. Without the parentheses, the calculator would give a value, but it would be wrong. So this is the way it's supposed to be entered. You get negative 1.75, and if you leave off parentheses, notice something came out, but it's not the same thing. What the calculator did was it actually did 9 divided by 4 first, which in fact is not what's supposed to happen with a fraction. So without parentheses, this is what the calculator did. It did 5 plus 9/4 minus 12. Okay, that's actually what the calculator did without parentheses. So watch out for that. You have to remember to actually put numerators and denominators in their own parentheses anytime they contain some sort of operation. So some examples. Use a calculator to evaluate the following. Well, quite frankly, even as you weren't told to use a calculator, I think the intent that you would anyway. So I've got, for number 1, 5 squared plus 2 all over 9 minus 3. Now, it's not difficult to do this by hand, but you need to be able to do it in your calculator. So if you don't have your calculator with you, be sure you can get this on your own when you try it, because again, it's a shame to get it wrong just because you made a few keystroke errors. So our solution. Okay, the numerator and denominator be in their own parentheses, because again, they contain these operations of addition and subtraction. So the numerator, it's in its own parentheses, the denominator is in its own parentheses. So here are your keystrokes. The opening parenthesis, 5, the caret key, 2, or if you want to, you could have just pressed the x squared key, plus 2, close parenthesis. That's the numerator. You now have the numerator. So divided by, that's the slash for the fraction, open parenthesis for the denominator, then 9 minus 3, close parentheses for the denominator, and then press enter. You'll get something that looks like this. So our answer is 4.5. Number 2, I've got 39 minus 4 all over 1 plus 2 times 3. Now again, the numerator and denominator contain operations, so they need their own set of parentheses. So our numerator, 39 minus 4, and there are the parentheses, then divided by for the fraction line, and then in parentheses 1 plus 2 times 3. Then you press enter to get the answer. The answer is 5. Again, these aren't difficult problems. They're just to make sure that you can get your calculator to calculate correctly. Rounding. Place value. You need to know the names of the place value. These are the place value names in the United States. Other countries have slightly different names. So in order to round correctly, we have to know the names of the different place values. We have the following chart for the names of the place values in the United States. So here's your decimal point. Going to the left, we have ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, and then as would come the billions, the 10 billions, the 100 billions, and then after that come the trillions and so on. Now on the right hand side we have tenths, hundredths, thousands, 10,000s, 100,000s, millions, 10 millions, and so on. Notice we have commas on the left-hand side separating three groups of numbers. We don't on the right-hand side. Now again, in the United States, it's commas, and this is one of the few times you don't put a space after a comma. Okay, these groups of 3 digits are called periods. Okay, now again, know the names of the place values. Now sometimes you'll be told, round to 3 places to the right of the decimal point, so it's kind of obvious, 3 places. So occasionally, instead of being given the name of the place value to round, you will be told how many places to the right of the decimal point that you're supposed to round. Be aware that our textbook like to round to the nearest hundredth, which is 2 places right of the decimal point. Now sometimes I will use hundredths, sometimes I'll use something else. So read the directions to know how many place values you're supposed to have. It's a shame to miss a problem just because you rounded incorrectly. So rounding itself. When rounding up to a particular place value, you need to look at the digit that is one more place value to the right of the place value if you're going to the right of the decimal point. If you're going to the left of the decimal point, you'd go one more place to the left. So we then obey the following rules. If the digit to the right of the place value to which we're rounding is 5 or more, we add 1 to the place value to which we're rounding, and this is called rounding up. If the digit to the right of the place value to which we are rounding is 4 or smaller, or does not exist at all, we do not change the digit in the place value to which we are rounding. This is called rounding down. Okay, the reason it's rounding down is because you're losing all those extra digits, so you're actually going to a smaller number. Now, of course, if you were rounding to the left side of the decimal point, you would change all these rights to lefts. Most of the time when we talk about rounding, we're either rounding to the nearest whole number or we are rounding to some number of place values to the right of the decimal point. We can also set the calculator to round for us. Okay, this will save us the agony of trying to figure out how to round. This is done in the mode menu. If we press the mode key, we get the following menu. So when we press mode, we get this. Now, depending if the 84, even some of the older ones, will not have all of these choices when you press mode, and the 83 certainly does not. The ones that really matter are float, radian, function, sequential, real, full. These others, it's nice if you have them, but it's no big deal if you don't. Okay, the math print is what's making the exponent look like an exponent. If you were to switch to classic, you would actually have the caret key followed by whatever the exponent is. So float is what we're going to use to change or tell the calculator how many places we're rounding. Okay? So 0 says have 0 digits right at the decimal point. In other words, round to the nearest whole number. 1 is 1 digit to the right. 2 is 2 digits to the right, and so on. So these numbers tell you how many digits to the right of the decimal point you're supposed to have. Float, which is the default, float just says display as many digits as there are. So in other words, kind of fill up the calculator screen. So it's display as many as the calculator can display. These other numbers here tell you how many places to the right of the decimal point are supposed to be displayed. So to round to a certain number of places to the right of the decimal point, we select the number to the right of the word float, and we would use our navigation keys or the arrow keys, and to scroll down to float and then go over to the right for how many places, and then just press enter. So to get out of the menu and go back to the home screen, you need to quit the screen. So quit is the second of the mode key. Just press second mode to get back to the home screen. some examples. Round 12.56397 to the nearest hundredth. Okay, we're going to the nearest hundredth. So remember, hundredth is 2 places right of the decimal point. So we look at the digit that is 3 places to the right of the decimal point. It's a 3, right? So since that's a 3, we're going to round down. So the 6 remains a 6, and we get 12.56. Now if you do it on your calculator, okay, we set our float to 2, okay, and then we would press enter. And then you can actually enter the entire number that's up there, 12.56397, and then just press enter, and it's going to do the rounding for you, because again, we've told it 2 places. So there's the entire number. Here it is rounded. Okay. If you're going to do a lot of rounding, just save yourself a lot of agony and possibly getting it wrong because you've rounded incorrectly. I would actually set the float in the calculator. You may as well let the calculator do as much of the work as it possibly can. There's no reason to strain your brain on just basic arithmetic stuff. So we're going to round again 12.56397 to the nearest 10 thousandths. Okay, 10 thousandths is 4 places. So 1, 2, 3, 4. Okay, and then we looked to the next digit after that. Now I've kept my float the way it is, so I've changed my float to 4. So I 12.56397, and then I just press enter and got 12.5640. Notice the calculator shows the 0 that you're supposed to have. If you're doing it by hand, you might not actually put the 0, because again, thousandths, or excuse me, 10 thousandths, you win 4 places. 1, 2, 3, 4. The 5th place is a 7, which makes that go up by 1. So if you add 1 to 9, you get 10, which makes that to a 4. Okay, the calculator did all the work for us. That's one advantage, again, of setting the mode. Now, if you have set the mode to something, don't forget, it stays that way even after you shut the calculator off. So if you want to avoid seeing weird stuff, you might want to set your float back to float. So the nearest 10 thousandths, the answer is 12.5640, and you do need the 0. If you don't have the 0, you don't have 10 thousandths. The order of operations. This is usually just called my dear Aunt Sally, or please excuse my dear Aunt Sally. Some students, they write PEMDAS. So symbols of grouping. Definition. When performing arithmetic operations, that should say performing, not perform. So when performing arithmetic operations, parentheses, brackets, and braces are called symbols of grouping or grouping symbols. The numerator and denominator of a fraction have what are called implied symbols of grouping around them. Okay, remember when we give it to the calculator, we have to put the parentheses around numerators and denominators. Now in the calculator, always use parentheses for symbols of grouping. Even though the brackets keys and the braces keys are there, they mean something entirely different to the calculator. And most of the time, all symbols of grouping are simply called parentheses. So we sometimes refer to all symbols of groupings as parentheses. On the 8384, the parentheses keys, which are the keys above the number 8 and the number 9, are used for symbols of grouping. Again, don't use the bracket or braces keys on the calculator. They mean something entirely different. So symbols of grouping are used to denote operations that must be done first. In the please excuse my dear Aunt Sally, the P is parentheses, right? So the operations that are inside symbols of grouping are done in the order presented on later slides. So on a calculator, you must put separate numerators and denominators in their own sets of parentheses if they involve any sort of arithmetic operation. You must also do this when typing a fraction on one line. This is the biggest error that students make in using their calculators. They'll get an answer and it'll drive them nuts trying to figure out what's wrong, and the first thing you should check is, do you have parentheses around your numerators and denominators where they needed them? So for example, 5 plus 6 over 18 plus 4 must be entered in your calculator as, again, parentheses around the 5 plus 6, parentheses around the 18 plus 4. If you get the correct answer of 0.5 or 1/2, when typing on one line, you must also type it like this. The parentheses are necessary. If you don't have the parentheses, you're really doing 5 plus 6/18 plus 4, which is 9 1/3. After all, 6/18 is 1/3. So if you don't believe me, just try it on your calculator and see what happens. So the order of operations. Now, all operations are done in the following order as the problem is read from left to right. Now remember, reading from left to right, that is how we normally read. So first of all, evaluate all expressions inside parentheses. For parentheses inside of parentheses, which are called nested parentheses, start from the innermost and work your way out. Okay, then the PEMDAS, that's the P. Second, evaluate all exponential expressions. That's the E. Please excuse my dear Aunt Sally. Okay, third, evaluate all multiplication divisions as you encounter them and going from left to right. So multiplication and division have what are called equal priority. So as you're reading from left to right, whichever one you see first is what you do first. So if you see division before multiplication, you would divide first. If you see multiplication before division, you would multiply first. So multiplication, division, equal priority. Fourthly, evaluate all additions and subtractions as you encounter them and going from left to right. Okay, addition and subtraction also have equal priority. So whichever one you see first and going from left to right, that's the one that gets done first. The usual thing that goes wrong with addition and subtraction is getting kind of loose with your signs. Now, of course, if you let your calculator do all the work, your calculator knows the operations. It knows the order of the operation. The only thing that you have to remember are numerators and denominators belong in their own set of parentheses. Of course, we'd let the calculator do all the work for us, and I think that's probably best. Some examples. Evaluate the following. Simplify all answers. Do not use mixed numbers or decimals in your answers. So this is meant to be done by hand. So first we have 4 to the minus 2 over 3 to the 4th. Okay, a negative exponent just says go to the denominator. So I'm going to have 1 over 4 squared times 3 to the 4th. This is by definition of the negative exponent. Now, according to my dear Aunt Sally, we do 4 squared and 3 to the 4th. So 1 over 16 times 81. You get 1 over 1,196. Whoops, let me go back and let me do this one on your calculator just so you can see. So I've got my calculator going here. Oops, I guess I've got to turn it on. Okay, so let's see, I've got 4 raised to negative 2. Okay, get out of the exponent, divided by 3 raised to the 4, and then just press enter. Okay, now notice I've got this weird looking thing, so to make it into a fraction, press math, and then the first choice says go to a fraction, so enter, and then enter again. I get 1 over 1,296, same thing we got here. Let me clear all that out. (18 divided by 6 times 3). Okay, there are no parentheses. I see division before I see multiplication. It gets done first. So I do 18 divided by 6, that's 3. So I now have 3 times 3, 9. For number 3, I've got this 8 minus 9 times 12 minus 5 times 8 plus 3. Okay, let me do this on the calculator first so you can see what's going on here. So let's see. 8 minus 9, open parenthesis, 12 minus 5, open parenthesis, 8 plus 3, close parenthesis, close parenthesis. We're getting 395. Okay, calculator says 395. Let's see what happens if we do it by hand. Okay, now I've got parentheses inside of the brackets, so I do the 8 plus 3 first. So I'm going to do the 8 plus 3 first. All this other stuff just kind of tags along. So I'm going to have 8 minus 9 times 12 minus 5 times 11. Okay, as I work my way out of the parentheses, I see this multiplication. So I'll do that next. So I'm going to have 8 minus 9 times 12 minus 55. Okay, I'm still inside the brackets, so I got to do 12 minus 55 next. So I have 8 minus 9 times negative 43. Okay, I now have multiplication to be done. Okay, I can do a negative times a negative is positive, or I could say minus a negative number, which is still positive. So I got to do the negative 9 times negative 43, or 9 times negative 43. Either way you do it, minus times minus is plus. So I'm going to have 8 plus 387, and I have only one operation left, 395, same as we got in the calculator. The disadvantage of the calculator, I guess, is you've got to key all that junk in. So it comes down to how fast are you with your fingers. Some special numbers. Okay, the calculator does have some built-in special numbers. So the calculator has 2 built-in special numbers. They are e and pi. Unless specifically told otherwise, always use the calculator's built-in values for pi and e. So e is about 2.718281824599045 and so on, and pi is about 3.141599265, etc., etc. So pi and e occur in many formulas of mathematics. They're not just mathematical curiosities. So on our keyboard, let me clear that. There's pi in blue, so you'd have to hit second pi. Whoops. Second pi there. And if you just press enter, there's the calculator's approximation. And e, it appears in 2 places. Here's one place for it. So second e, and just press enter, and there's the calculator's approximation of it. And it's also down here. Notice that's e to the x. And it's waiting for you to give it an exponent. So if I had e to the 5th, there. Okay. So you use this one if you just want the number e. You use the one down here, which is if you want to take e to a power. Most of the time you're taking e to a power. Now again, they're in blue, so that means you have to hit the second key first. Now if you do have the 83, let me bring up my 83. Notice what's in blue is actually in orange on the 83, so whoops, I guess I got to turn it on. So second pi, and again there's its calculation, second e, and then second e to the x. Notice it has the caret, and it's already got the opening parenthesis to have the exponent. Like if you had 5 times 3 as my exponent. Okay. So again, this is the 83, or technically 83 plus, which just means it has more memory than the regular 83. And this is the 84 silver edition. Let me close that one. Yeah, I guess I don't need this one for the moment. So some examples. A certain radioactive substance behaves according to this formula. Q is equal to 500 times e to the negative 0.0155 t, where t is time in years. Q is number of grams present after t years. It says use the above formula to determine the number of grams present after 15 years. Round your final answer to the nearest hundredth of a gram. Okay, now notice we're given a value of t, so t is 15. So hundredth, again, is 2 places, so I'm going to set my float to 2. So here are my keystrokes, 500, second ln, and then there's the exponent, times 15, and press enter. Okay? So again, let me take out the calculator and show you. So I do my mode. I'm going to float over to 2. I got to quit that screen. And I do 500. You don't even need to say time. The calculator knows. Second ln negative 0.0155 times 15, and then just press enter. And there it is, 396.27. This 0 right here, that's all by itself to the left of the decimal point, that's called a leading 0. You don't need to put it. Okay, I just get in the habit of doing it, but you don't need to put it. And when we start counting zeros, we don't really count it. Okay? Just so you'll know that I've set my float to 2. If I do something like this, 0, and I press enter, it rounds it to 2 places. Okay, this is how you know that your float is set to something that you don't want it to be. So we have 396.27 grams are present after 15 years. Number 2. It says the surface area of a sphere of radius r is given by s equals 4 pi r squared. Find the surface area of a sphere that has a radius of 9 inches. Round your final answer to the nearest hundredth of a square inch. So again, hundredth is 2 places, so I've already got my calculator float to 2. So my keystrokes are 4 pi times 9 x squared. Okay? And then you press enter. So again, let me show you how I did it. Okay, 4 second pi times 9, and I press the x squared key this time. Notice if you're just doing x squared, it comes out of the exponent all by itself. 1017.88, and these are cubic inches, or excuse me, square inches. It's surface area, not volume. Shouldn't say surface area, not volume. So again, my little note here, pi is the second of the caret key. And again, that should say surface area, not volume. It says evaluate e cubed plus pi over 2 pi plus 5. It says round your function to 4 places right at the decimal point. Okay, so our solution, if we wouldn't do it on our calculator, okay, 4 places, so let me change my float. Let me clear this out. So mode, I want to float over to 4. Press enter. Quit the screen, second quit. So now open parenthesis for the operation of the numerator. So second e to the x, 3, get out of the exponent, plus second pi, close your parentheses, divided by, open parentheses, 2 second pi plus 5, close parentheses. Now, if you forget to close parentheses, it's going to close it at the very end. So if you have a bunch of them opening, a bunch of opening parentheses, it closes every single one at the end, whether that's where they're supposed to be or not. And then just press enter. So to 4 places, 2.0586. So there are my keystrokes. So open parenthesis, second ln, 3. This is the navigation key to get me out of the exponent. Then plus pi, close for the numerator. So all this stuff right here is the numerator. Again, this was the right navigation key to get out of the exponent. Then divided by, for the fraction line. And then here is your denominator. 2 pi plus 5, denominator in parentheses, press enter. That was the screen we got. So 2.0586. Scientific notation. Okay, without a calculator. Okay, without a calculator. So scientific notation is a way to write numbers that are very large or very small in absolute value. So the format for scientific notation is this: capital N times 10 raised to the little n power, where capital N is equal to a number that has exactly one non-zero number to the left of the decimal point, and little n is an integer that counts how many places the decimal point and capital N must be moved in order to restore the number to its original value. If n is positive, the decimal point and n is moved to the right, and if little n is negative, the decimal point and capital N is moved to the left. A number that has non-scientific notation, something like 15,709, is said to be in decimal form, standard form, or normal form. In standard form, we normally put a comma after a group of 3 digits beginning at the decimal point and going to the left, like right here. Remember, this comma is for the punctuation of the sentence. This comma is for the number. These groups of 3 digits are called periods. There's a period. There begins another period. And we normally say separate periods by commas. So write each of the following in standard form. Separate periods by commas. So I've got 4.013 times 10 to the 7th. Okay, that's 7, that exponent of 7, means we need to move the decimal point 7 places to the right. Okay, 7 places to the right. We already have 4 places to the right. So our number of zeros is going to be 7 minus 3, so we have to have 4 zeros at the end. So I have 4013 and then 4 zeros. Okay, now I'm going to put my commas in. So remember, groups of 3 digits. 40,130,000. Again, remember, it's commas, not spaces. Our second one, negative 8.9133 times 10 to the 11th. Now please don't lose that minus sign, which is making the number negative. So I've got an exponent of 11, so that means I have to move our decimal point 11 places to the right. Now I already have 4 digits to the right of the decimal point. So the number of zeros I need, 11 minus 4, I need 7 zeros to the right. So negative 89133, and then tack on 7 zeros. Okay, now we put in our commas to separate the periods. So we've got negative 891,333,000,000. Again, don't lose the minus sign. That makes the number negative. Number 3, I've got negative 2.062 times 10 to the minus 6. Okay, this minus sign is making the number negative. The minus 6 says move your decimal point, this decimal point, 6 places to the left. Okay, we already have 1 place to the left. Remember, there's always going to be 1 digit to the left. So we need 6 minus 1, we need 5 zeros in front of the number. So negative 0 point, now remember, don't count that 0. It's these zeros, I should have 5 of them. And then 2062. Now remember, no commas for places to the right of the decimal point. And again, this leading 0, you don't need it, but you also don't count it. So again, the notes, there are no commas on the right side of the decimal point. And number 2, the 0 to the left of the decimal point, again called the leading 0, is not counted as one of the zeros that we add. You do not need to put it if you don't want to. Okay, it's entirely your choice. I just have a habit of doing it. And remember, a decimal point. Okay, the United States uses decimal points, not commas. The rest of the world, where we have a decimal point, they put a comma, and where we have commas, they put spaces. Number 4, 4.103 times 10 to the minus 4. So our solution, minus 4 says move the decimal point 4 places to the left. We've already got 1 place to the left. Remember, there's always 1. I'm going to have 4 minus 1, or 3 zeros in front. I have 0.3 zeros and then 4103. Some more examples. Write each of the following in scientific notation. So you have to think backwards now. I've got 15,900,000. So our capital N is just the 1.59. And remember, the decimal point that we don't see is right here. Okay, if you don't see it, it's at the very end, on the very right. So I want to move this one so that it's between the 1 and the 5. So I've got 3, 6, 7 places. Remember, in order to restore it back, I have to move it back right 7 places. So our little n is 7. So this is going to be 1.59 times 10 to the 7th. Okay, notice the scientific notation just kind of lops off these zeros that no one cares about. Number 2, I got negative 1,600. Now again, don't lose the minus sign. Our capital N is negative 1.6. Remember, the decimal point was originally here. I want to move it between the 1 and the 6. That's 3 places. Okay, so our little n is 3. So we're going to have negative 1.6 times 10 to the 3rd. I've got negative 0.000058. Our capital N is negative 5.8. Okay, I want this decimal point to move between the 5 and the 8. So it's got to go 1, 2, 3, 4 for the zeros, and then one more for the 5. So in order to restore the number, I have to move it back to the left. So our little n is negative 5. So I'm going to have negative 5.8 times 10 to the negative 5. Most students will like this when it's a decimal thing. They just count those zeros and add 1, because that's what happened. And don't forget that the exponent is actually negative, because we've got to move the decimal point back to the left to restore the original number. Okay, number 4, I have 0.000009. Okay, our capital N is 9. Okay, I put the point 0. You don't have to. You can just call it 9. Okay, again, count these zeros. 1, 2, 3, 4, 5, 6. So our little n, remember, add 1 to that is 7. So our little n is negative 7. So I've got 9.0, or if you just want 9, times 10 to the minus 7. Again, you could just say 9. Okay, with a calculator. Entering numbers in scientific notation in the calculator. So a number in scientific notation by hand looks something like this. 3.104 times 10 to the 7th. Now, the base of the exponential part here is always 10. So the same number in scientific notation in the calculator looks like this. 3.104 with a little subscript, capital E, 7. Okay, that's what it looks like. Okay, the E stands for exponent. So it means the exponent on the 10, because the base is always 10. Now, don't you guys write this as an answer to something. I mean, write it the way a human would write it, not the way the calculator writes it. So the E stands for exponent. It is the value of little n. Okay, to enter the exponent, press EE key. For some reason on the keypad it's called EE. It is the second of the comma. That is the key above the 7 key. So on the calculator, it's right there. Okay, there's EE. So it would be second EE. So enter the following scientific notation numbers into the calculator. So we're not going to do anything with them, we're just going to enter them. So negative 4.12 times 10 to the 9th. So you're going to have negative 4.12, then second, EE, 9. Okay, you get this. So again, if we do it on our calculator, okay, let me turn it on, I guess. Clear that out. And let me set my float back to float. And quit that. So, negative 4.12 second EE 9. Okay. Now, if you press enter, it gives it to you in standard form. It just doesn't put the commas. 3.014 times 10 to the negative 8. So you're going to have 3.04 second EE, negative 3. you're going to get something that looks like that. Now, if we were to press enter, you actually see the same thing. Okay, it won't, on the calculator, it won't do anything to it. It's one of the limitations of the calculator. Let me figure that out. So let me just show you that. 3.014 second EE -8. If I press enter, same thing. Okay, the calculator cannot convert that number back to standard form is what it means. Remember, it could be on the other one, but it couldn't do that one. So converting to scientific notation. So we can convert numbers that are in standard form to scientific notation by changing the mode. We change the mode from normal to SCI, which stands for scientific notation, then press enter. Pressing the mode P gives you this screen. Okay, and right there is SCI. Okay, this is what's highlighted is normal. Okay, and you can actually see it right there. So then we navigate to SCI and press enter. Okay, so once we have calculator in scientific mode, these are the steps to convert from standard to scientific. We actually kind of saw it. Enter the number in standard form to the calculator, then press enter. Okay, so you should see the number in scientific notation. Remember, the E gives the exponent on 10. So convert the following to scientific notation. There's our first one. So we're going to enter that number. Okay, we're going to press enter, and you get that. Okay, so again, on the calculator, clear this out. Mode, go to scientific, press enter, quit the screen. Okay, then -625. And see, how many zeros did I have? Let's use it to count over here. 3, 6, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Press enter. There it is. Okay. A lot easier than trying to do it by hand. The calculator can do a whole lot of things if you know all the stuff. Should be a course all by itself. Okay, so our answer is -6.25 times 10 to the 12th. Okay, remember, that's how we'd write it, times -6.25 times 10 to the 12th. Don't write this. We got 0.00000366. Okay, if we try to do it on the calculator, we're going to write the number and then just press SCI. Okay. So again, on our calculator, if we do it, remember, I've already got it set in scientific mode. So, whoops, I got 0. How many zeros do I have? 1, 2, looks like 5. 1, 2, 3, 4, 5, 3, 6, 6. Enter. Ta-da. So our answer, 3.66 times 10 to the -6. Converting to standard form. So we enter the number in scientific notation in the calculator, and be sure that the calculator is in normal mode, and then just press enter. So warning, if the number is less than 0.001, that should say, which is 10 to the -4 in absolute values, then the calculator will not convert it to standard form. Okay, that's because we had that one that had the exponent of -8 and it couldn't convert it back. Okay, that's what happens. For whatever reason, the TI calculators, if the number is less than 10 to the -4 in absolute value, it cannot convert it back to standard form. In fact, if you give it a number that's less than 10 to the -4 in absolute value, it will give the answer in scientific notation, and there's no way to make it stop doing that. So convert the following in standard form, separate periods by commas. So I've got 5.113 times 10 to the 8th. Now we've already done it by hand, so if we do it on the calculator, okay, again, let's go back to normal mode. So mode, highlight normal, press enter, quit the screen. You can actually, you'll even need to enter in scientific notation. You can enter it the way it looks. 5.113 times 10 raised to the 8th power, and there it is. So I've got how many zeros there? 5. So then I put in my commas. 511,300,000. 3.09 times 10 to the -3. So again, if I do it on the calculator, 3.09. Let me do the EE thing second. EE -3. Enter. 0.00309. Now again, because it's greater than 10 to the negative 4 and a half value, it was able to do it. So 3.09 times 10 to the minus 3 is 0.00309. Meaning of percents. So this is just going to be a bunch of calculations for you. This is to prepare you for some of the homework and quiz problems for the chapter P. So the definition. The word percent means divided by 100. So 12% means 12 divided by 100. So 100% is 100 divided by 100, which is 1, or 1.0. So keep that in mind when converting between percents and decimal numbers. Notice the decimal number looks smaller than its equivalent percent. So remember, percent just means divided by 100. Converting between percents and decimal numbers. Now, since we're going to be doing our calculator, we're going to stick with the decimals. We're not going to try to do the fraction nonsense. So percents to decimals. So I give you a percent number, you want to go to a decimal number. It all goes back to the meaning of the word percent. We're going to try to keep this as simple as possible. So the method for converting a percent to a decimal number. Step 1. Move the decimal point 2 places to the left. It may be necessary to add some zeros. This is the result of dividing by 100. Because remember, percent means divided by 100. And then step 2, remove the percent symbol. That's all you're doing. So you just divide by 100, remove the percent symbol. Some examples. Convert each percent to a decimal number. Do not round. So I've got 65.78%. So you're going to do 65.78 divided by 100 and leave off the percent symbol. So again, if you have to do it with your calculator, I mean, there's nothing wrong. I mean, that's why you bought it. So 65.78 divided by 100. 0.6578. That's all you do is just divide by 100. Number 2, 458.99%. So you're going to do 458.99 divided by 100 and get rid of the percent symbol. So if you do 458.99 divided by 100, you're going to get 4.5899. Okay, you're just dividing by 100, which means move the decimal point 2 places to the left. Number 3, 0.128%. Okay, again, you're going to do 0.128 divided by 100. I'll leave off the percent symbol. So if I do the agony here, 0.128 divided by 100, if I can do it here, 0.00128. Again, the leading zero, it's your choice. I have a tendency to put it, but it's your choice. Okay, decimal numbers to percent. So we're going the other way. We're going from a decimal number to a percent. So method for converting a decimal number to a percent. Okay, it's just the opposite of what we did. So move the decimal point 2 places to the right. It may be necessary to add some zeros. Okay, this is accomplished by multiplying by 100. So remember, previously we said divide by 100. This one, multiply by 100. And previously we said remove the percent symbol. We're going to put it back. So step 2, append the percent symbol. So multiply by 100, add on the percent symbol. So notice if you have the percent symbol, you divide by 100. If you don't have the percent symbol, you multiply by 100. So that should say right and, not right and. Write an equivalent percent for each decimal number. Do not round. So I got 7.588. So you're going to do 7.58 times 100 and add the percent symbol. So you're going to get 758.8%. Number 2, 0.7588. So you're going to do 0.7588 times 100 and add on the percent symbol. So you're going to get 75.88%. Number 3, 0.007588. So you'll do 0.007588 times 100 and add on the percent symbol. So you're going to get 0.7588%. Now most of the time, if you're going to do something with a percent, you need to convert it to a decimal number. So the basic percent equation. Okay, the basic percent equation is this. A is equal to R times B. Some people will say A is equal to B times R. Okay, and some people, instead of using A, they'll use a P. I don't like to use the P because people confuse it with percent. So now, what do these letters stand for? A is equal to the amount. The amount is also known as the piece, portion, or part. That's why some people use P. So the amount is typically the value near the verb of being. Verbs of being are is, was, were, will be, must be, could be, and so forth. So again, the amount, the A, it's near the verb of being, usually. R is the percent rate. That's why it's called R for rate. It is typically the value with the percent symbol. So if R is not the value with the percent symbol, then R is equal to 100% minus it, or 100% plus it. R must always be converted to a decimal number. Okay? So again, the number that has a percent symbol, that's R, or else R is going to be 100 plus that, or 100 minus that. B is the base. The base is also known as the whole or entire quantity. It is typically the value after the word of. Now, because the amount is a piece or portion of the part, students believe that A should always be less than B. It doesn't have to be. Remember, we can have percents bigger than 100. So if the percent is bigger than 100, the piece will be bigger than the whole. The confusion comes in is between which is A and which is B, because R always has the percent symbol with it. Now remember, the amount, the piece or portion, the A, it's near the verb of being. The base is near, usually after the word of. Let's try some examples. So the basic percent equation is saying this: amount equals rate times base. Well, before we do the examples, there's actually a nice little picture of the basic percent equation. So the picture of the basic percent equation, we have this circle in the, we got it in half. In the northern hemisphere is A. The southern hemisphere is cut in half, and one side is B and one side is R. Again, it doesn't matter which side is B or R. This is how it works. You'll always be given 2 out of 3 of the values. Okay, you have 3 values, A, B, and R. You'll be given 2 of them, and you'll be asked to find the third one. So to find the third or unknown value, you cover it up on the circle. And then whatever's left tells you how to find that value. So to find A, if you're given bar, so cover up A. If you look at what's left, you basically have BR. Remember, BR means B times R. So to find A, you do B times R. If you're looking for B, okay, cover it up. You now have A over R. So to find B, you look at A divided by R. And to find R, cover it up. You're going to have R is going to be A over B. So you're going to do A divided by B, which means you're going to get a decimal number. Remember, R is a percent. So to do the decimal number, you then have to convert it to a percent. Remember, to convert the decimal number to a percent, you just say times 100 and add on the percent symbol. Okay, notice 2 out of 3 times you're dividing. Okay, so again, remember, whatever you're looking for in this little picture, covered up, and whatever operation looks like is there, that's what you're going to do. Finding R is the one that has the extra step. You got to do times 100 to convert it to a percent. Let's try a few. So we'll look at examples in a moment, though. So the basic percent problems. There are 3 types of basic percent problems. That is why the textbook had 3 sections devoted to the basic percent equation. Okay, the 3 types of basic percent problems look like this. What is X percent of Y? What percent of X is Y? And X percent of what is Y? Notice in 2 of them, the percent symbol is there. So in 2 of them, you're not looking for R. You'll be given it. It's the what percent of X is Y. There's no percent symbol, so you're looking for R. So whenever there's a percent symbol, you're not looking for it. If there is no percent symbol, then that means you're looking for R. Now, it doesn't matter if you know which type is which. Let's just try some. So in all of cases, X and Y will be numbers or values given to you in the problem, or else somehow made known to you. You're looking for the what. Word problems are just cleverly disguised versions of the above 3 types of problems. Okay, notice that in the 2 types, then 2 of the types, the percent symbol is given. In the third one, it's not given, so we're looking for R. So it does not really matter if you can or cannot recognize which type of basic percent problem it is. It really doesn't matter. I'm never going to ask you something like that. Is it type 1, type 2, or type 3? I'm never going to ask you that. You just have to be able to solve them. So some examples. What is 52.1% of 18? Do not round your answer. So our solution. We draw our little circle. B is 18. Remember, the base is typically after the word of. Okay, I see the percent symbol. That's R. So R is 52.1%, which is 0.0521. Remember, always convert your percents to a decimal number. A is, I don't know. So we covered up. So just A is B times R. So I've got 18 times 0.521. So you just take out your calculator and do 18 times 0.521. You get 9.378. Okay, notice there really was no reason to round. Okay, anytime we want you to round, it's going to say something about rounding, how many decimal places you're supposed to show. If you don't see anything about rounding, don't do it. Number 2, find 78% of 102.3. So again, our solution, there's your circle. Okay, I've got something after the word of. That must be the base. I've got a percent symbol. That must be R. 78%, so 0.78. A is missing. Covered up. A is B times R. So 0.78 times 102.3. And you get 79.794. Number 3. What percent of 85 is 53.55? I don't see the percent symbol. So we're looking for R. So our solution. Again, there's our basic percent picture. So R, we don't know. I don't see the percent symbol. The base, 85, it's after the word of. Okay, the number that's near the verb of being, 53.55. Notice, so is 85, but 85 actually was after the word of. That's how I knew it was the base. So that has to be A. So we're looking for R covered up. R is A over B. So I'm going to do A, 53.55, divided by 85. You get 0.63. Now remember, I wanted a percent. I got a decimal. So convert 0.63 to a percent. Do times 100, 63%. Remember, to convert the percent, to convert the decimal to percent, just say times 100 and tack on the percent symbol. Number 4, 15 is what percent of 40? Okay, we draw our little circle. Okay, I don't see the percent symbol. So R is, we don't know. Okay, I've got 15 and 40. I've got to decide which is A, which is B. Okay, 15 is near the verb of being. 40 is after the word of, makes it the base. Looking for R. It's A over B. So 15 divided by 40. You get 0.375. Convert it to a percent. Say times 100. 37.5%. Number 5. 27% of what is 81? Okay, our solution. We draw our little circle. So 27% of what is 81? The R, 27%, 0.27. Okay, the 81, it's near the verb of being. That makes it A. What is after the word of? What is I don't know. So the base is I don't know. Looking for B, covered up. It's A over R. So I'm looking at 81 divided by 0.27. You get 300. Remember, it doesn't go to a percent because I got the percent symbol in the problem. Number 6. 15.75 is 105% of what number? So our solution. Okay. I see the percent symbol, so I'm not looking for R. So R is 105%, which is 1.05. The 15.75 is near the verb of being, so it's A. The what number is after the word of, so that's our B, is I don't know. We're looking for B, covered up. It's A over R. So 15.75 divided by 1.05. Now notice our percent is bigger than 100%. So the part, the A, will be bigger than the whole. The A will be bigger than B. So I'm looking at 15.75 divided by 1.05. You get 15. Okay, percent increase, percent decrease, and percent change. In general, percent change takes care of both of these. If when you do the calculations you get a positive, that's a percent increase. If you do the calculations you get a negative, that's a percent decrease. If you just ask for percent change, you have to include the plus or minus. If it actually says the word percent decrease, you don't need the minus. So definition, the percent increase or decrease of a quantity is an increase or decrease in that quantity expressed as a percent of its original amount. Percent change refers to either percent increase or percent decrease. Again, if you do the calculations, you get a negative number, that's a percent decrease. If you do the calculations, you get a positive number, that's a percent increase. There's a formula. So here, but the method for finding the percent change. Step 1. Find the difference between the original value and the new value. The original value is typically after the word from, or the word originally. The new value is usually after the word to. Step 2. Divide the result of step 1 by the original value, the value after the word from or the word originally. So notice two numbers are going to appear twice. Step 3. Convert the decimal number from step 2 to percent. So you're going to move the decimal point 2 places to the right and append percent symbol. Remember, that just amounts to multiply by 100. So just multiply by 100 and tack on the percent symbol. So these three steps are going to lead to the formula. So the above method leads to the following formula for finding a percent change. It's the new value minus original value divided by original value times 100%. Okay, again, the times 100% converts the decimal number to a percent, because 100% is really 1. So it's new value minus original value divided by original value times 100%. If the above result is positive, then that means we had a percent increase. If the above result is negative, then that means we had a percent decrease. Typically, we do not put the minus sign in the answer. So in the following examples, we'll have a percent change problems as well as general word problems on percents, because this is our last topic in percent stuff, so I can give you anything now. So some examples. Answer the following. Do not round unless instructed to do so in the problem. A lot of times students will round even though it never said round. And of course that leads to things getting marked wrong. So here's our first one. An item normally sells for $67. It has been reduced to $45. Find the percent decrease in price. Round your final answer to the nearest tenth of a percent. Remember, tenth of a percent is going to be one decimal place after we've converted to a percent. So our solution. Okay, it's going from 67 to 45. So 45 minus 67 over 65 times 100%. Remember, going from 67 to 40, going from 67 to 45. So we do the calculations. You get negative 32.8358, blah, blah, blah. Then just say times 100. Oh, I already did that. I'm sorry, my mistake. So we're running to near to tenth, so negative 32.8%. So now it did say 5% decrease. I got a negative number, so I didn't really make a error in my places here. So the percent decrease, 32.8% decrease. Okay, again, let me show you on the calculator in case you're curious. I suppose I should turn it on. Clear. So I want to do everything on my calculator. Let me set my mode to, it said tenth, so let me set my float to 1. Enter. Quit. Okay. 45 minus 67. Whoops, lost my 6. 67, close parenthesis, divided by 67 times 100. Negative 32.8. Number 2. Find the percent increase in going from 15 to 22. Round your final answer to the nearest tenth of a percent. So from 15 to 22. So we're looking at 22 minus 15 over 15 times 100%. So again, if we give it to the calculator, open parenthesis, 22 minus 15 close divided by 15 times 100. 46.7%. Remember, the counter was already doing the rounding for us. We set our float. Okay. So 46.7%. At a summer camp of 40 boys and girls, 35% of the campers are girls. How many of the campers are girls? So this is not a percent increase, decrease. So our solution, we draw our circle. Okay. I'm not looking for R, I see the percent symbol. Now, the whole is all the boys and girls, so that's 40. My R, 35%, 0.35. Okay, the girls are part of the whole, so I'm looking for A, which is, I don't know. So A is B times R. So I'm going to have 40 times 0.35, 14 girls. Number 4, if the sales tax is 6.75%, find the amount of tax that should be charged on an item that costs $78.99. Round or final answer the nearest whole cent. Okay, we're just looking for the tax. So our solution, okay, there's our basic percent circle. The B, it's 78.99. In tax salaries, the base is always before tax or before a raise or before a salary reduction. In terms of items going on sale, it's the price before the sale. Our R, 6.75%, which is 0.0675. The amount of the tax is, I don't know. So A is B times R. So 78.99 times 0.0675. To the nearest cent, $5.33. Now, if you wanted to know what was the whole bill, it's the purchase price plus the tax, right? Okay, so again, remember, for tax, sales tax, items going on sale, and salary increases and decrease, the base is always the price before tax, the salary before an increase or deduction, or the original price of the item before it went on sale. Number 5, after a 7% pay raise, Susie's new salary is $48,685. What was her salary before the raise? So notice the salary before the raise, that's the B. Okay, that's the B. So our ABR. Now, first of all, the R, it's 100% for the salary before plus the raise. So 107%, so 1.07. Again, the 100% is for the original price, the original salary. Okay, the 7% is the amount. Because notice it says her new salary, so that's after she got her raise. Okay, so the A is $48,685. Remember, the base is always before the raise, before the item goes on sale, before you put in the tax. So we're looking for B. It's A over R. So we're going to have $48,685 divided by 1.07. $45,500. So her salary before the raise is $45,500. Again, remember, in these types of problems, the base is always the original amount before you had a raise or a reduction. It's the original amount before you added tax. Number 6, an item goes on sale for 40% off its original price. If the sale price is $375, what was the original price? So notice, this is after the sale price. The B is original price. So here's our little basic percent circle. Okay, the 40% off. The R is not the 40%. The R is 100% minus the 40%. Okay, so 100% for the original price, and then here's your 40% deduction. Okay, we know we're supposed to do this because we have the price after it went on sale. Notice this is kind of the reverse problem of getting a pay raise. Okay, the A is $375. The B is original price, so we don't know. Looking for B again, it's A over R. Now remember, if it went on sale, B had better be bigger than $375, otherwise they cheated you. So B is going to be A over R, so 375 divided by 0.6, you get 625. So before the sale, the original price, $625. Number 7. The population of my town in 2000 was 15,120. In the year 2010, the population went to 21,880. Find the percent increase. Right, the final answer there is 1/10 of a percent. Okay, our calculator is still set up to be in the correct mode. So we're going from 15,120 to 21,880. So we're going to do 21,880 minus 15,120 divided by 15,120 times 100%. Remember, it's always the new minus the original divided by the original. So when we do the calculations, 44.70899% to the nearest tenth, 44.7%. So we had a 44.7% increase. That's the end of Chapter P.